Hey, what's up? Welcome back. This is day 7 in the Advent of Code. We're going to be working on this group of crabs that are all sort of trying to figure out how much fuel the crabs take to get to a certain point. It should be a fun one. And I think this is probably best solved with some sort of dynamic programming tools or something. But when I solved this, I just brute forced it. So that's what we're going to do today. So the idea is that we receive in some list of horizontal positions of a crab, and it costs a crab some sort of like fuel to move towards some other position. And what we want to do is we want to figure out a line where we can line up all the crabs. So like if there was a crab on 16 and we want to move it to 2, then that costs that crab 14 fuel to move to number 2. If a crab is on 1 and we're moving to 2, then it costs them 1 fuel. So the first part of this is that we want to find sort of the range in between where the crabs are located. So we want to find the minimum point. That's going to be kind of like the leftmost point where a crab might be located. We also want to find the maximum point. That's going to be like the farthest right that a crab might be. And then we're going to iterate over every single middle position and count or like calculate how much fuel it costs for all the crabs to move to that middle position. And then ultimately, I guess the answer is like how much fuel it costs to move to that middle position. So let's crack open our Advent of Code stuff here and add day 7. So we're going to add day 7, and we're also going to add a spec for day 7 spec.rb. Require relative day 7 crabs.rb. rspec.describe crabs. Crab? I don't know. It's like a collection of crabs. Is that like a school or something? I don't know. Let's go look. What is a group of crabs called? And while that's coming up, we'll say it calculates the fuel to move to a new position. And I guess like what we really want is just kind of like, I guess, what is this? A consortium. A group of crabs is called a consortium. That sounds way cooler. We're going to have our class be called a consortium. I don't know if we'll be able to spell that. Okay. So the idea here is that we're going to have some consortium.new, and that's going to take in some positions, and that's the positions of the existing crabs, and we want to expect that c.min fuel, like the minimum fuel that it costs to move all those crabs from some position to some shared middle point, is going to equal something. And so let's just, let's see here. So like we'll grab all of our example positions and let's just pass those in as our test here. And then we're going to expect this to equal 71. Now this is like kind of jumping to the end, right? Like where this test is really kind of, expecting that we have a bunch written already. And I'm not exactly sure what it's going to look like. So let's just go over to crabs.rb. I guess like a class is consortium. Is that consortium? Consortium? I think it's, I don't know, Shium. And then we're going to take in positions. Positions is positions. That's like where the crabs are located. Positions. Okay, and then we want to calculate like the minimum fuel that it takes. So this is kind of like min fuel. And again, like, you know what? We should probably figure out like what is the range. So it like calculates the range correctly. I don't know if this is a valuable test. Like this is going to be such a simple thing. So maybe we have like expect c dot min pos to equal 0 in this case, and then max pos to equal 16. This is, I don't know like how helpful these are. Min pos, max pos And that's just going to be like positions.min and positions.max. Not super sure how valuable that is. All right, let's just work on calculating the minimum fuel here. So the idea is that we want to figure out how much it costs to get to a certain point. So maybe what we should do is say like fuel for n, like the fuel cost for n, and then we'll pass in a point, and that will tell us how much it costs to move all the crabs to that position. Yeah, that's like a smaller jump. So just like it calculates fuel for a specific position. And again, remember that we're like trying to figure out what is like the most affordable center line to move all the crabs to. So let's say that we have like this consortium thing again, and I think we want to start with like really basic numbers. So if we start in here with just like 1, 2, 3, we can expect that what is it? Fuel for 2.2 equal, well, it's going to cost this crab 1 to get to 2, and then it's going to cost this one 0. It'll cost this one 1, so we expect that to equal 2, right? So if we run this, that should equal 2. Wait, did that? Oh, c.fuel. Okay, expected 2 got nil. So what we want to do now is we want to say like min pos dot up to max pos dot each do. Actually, no. This is going to be part of this thing. So the fuel is going to be iterate over all the positions and calculate how much it costs to move there. So at fuel is 0, and then that's what we're going to return is at fuel. And the cost is going to be for each position. We want to see what the difference is between n and that position. So it's going to be positions dot. Actually, this fuel is just going to be, we can calculate it from positions directly. Positions dot inject 0 do fuel, and the fuel is going to be fuel, and the position is going to be fuel plus position minus n dot absolute value. I think that's what we want. Okay, implicit conversion of integer to array. Positions.min, positions.max, fuel of n. So we pass, we're passing in positions. Yeah, that should not be an array. It should just be, it's already an array. So I messed that up. Let's see. Okay. All right, so we've got that's passing. Let's write another 1, 2, 3, let's see. We'll just like make another assertion that moves us a little bit further, 5 and 9 or something. So the cost to go from, and then we'll calculate the fuel to like 3 or something. So from 1 to 3, that is 1 to 3 is 2, and then 5 to 3 is 2, and 9 to 3 is 6. So we should get back 10 here, I think, and we do. Okay, so all of those are passing except for this min fuel that we've got going on below. So what we want to do now to figure out our minimum fuel is we want to figure out the fuel for all possible positions in between, and we want to find the minimum. So min fuel, I'm going to actually create, also like as I'm going through this, if I'm creating a variable that has the same name as the method, that's called like shadowing or variable shadowing, and that's what we're going to return. Min fuel, and I'm actually going to set min fuel to infinity, and the reason is we want to start off with like a really big sentinel value, and then we want to see like as we check each possible position between the minimum position and the maximum position, if we're getting a minimum fuel that's smaller, then we want to update min fuel to a smaller value. So here we set min fuel, we started off at infinity because nothing is going to be bigger than infinity. Things will only be smaller. So the very first time that we check some value, we should get a smaller value. So we can say like F is fuel for N. If F is less than min fuel, then set min fuel equal to F, and then we end. And then this final thing should do something. So we expected 71 and we got 37. So what is going on here? So fuel, positions in Jack 0, fuel, okay, blah, blah, blah. All right, so one thing that we want to do is make sure that we got to make sure that our numbers are being calculated here correctly. So it seems like maybe this is wrong. So what I'm going to do is I'm going to use positions from the example, and then we're going to pass in 2, fuel of 2, because fuel of 2 is 30. Oh, wait, hold on. 37 was the answer. 37 was the answer. So this should have been 37. So instead of 71, this should have been 37. So we'll run that again. All right, that passes. So, okay, so now we should be able to at least calculate that position. All right, that's fantastic. Let's take a look at, so my puzzle answer was 344735. So we'll get our puzzle input here, copy all of that, input, okay, and then we're gonna do our if file. File.read lines or I guess, yeah, file.read the whole thing, arg v.first.chomp.split on comma.map to I. This is going to be our positions, and we'll just p positions just to make sure that we're starting off right. And this is going to be day 7, crabs.rb, day 7 input. All right, that looks good. So then we want to create our consortium of crabs, consortium, C equals consortium.new positions, and puts c.min fuel. And all right, 344735. So that is part 1 of the day 7 advent of code. We are able to sort of like figure out which point we move to and then which is the best. And the other thing that's kind of cool that I didn't really show is that like we're not actually keeping track of which position it was that was the best position, but we could do that here. Like we could just keep track of like best pause or something, just to see like what is the answer, or like on which line are we best aligned. Okay, so part 2. Part 2 says, the crabs don't seem interested in your proposed solution. Perhaps you misunderstood crab engineering. Very possible, very possible. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of 1 step in a horizontal position costs 1 more unit of fuel than the last did. So on the first step, it costs 1. The second step, it costs 2. The third step, it costs 3, and so on. So like if you're moving from position 1 to position 5, or 0 to 5, then you have like a 1 plus 2 plus 3 plus 4, right? And so what I think we want to do, instead of just adding the absolute value here, like I think we need to figure out, we want to figure out the sum of values between 0 and whatever this is, right? So like, I guess we can say like, if you sum all the numbers between 0 and some number, the answer is n, like n plus, or like n times n plus 1, and then you divide the whole thing by 2. That gives you the answer for like the sum of numbers that go up from 0 to some number. And so what we want to do here is like, this is our n equals this thing. And then our fuel, I think, is going to go up by n times n plus 1, and then the whole thing divided by 2. And that we just want that to be like by itself. So I'm going to be super explicit with the parentheses there. If we run this, we get back an answer that is wrong. So that answer is way too high. So what we've got to do now is let's update our test here. So yeah, so if we try to run these tests now, they're going to fail because we're getting different numbers, because part 2 has different values. So now instead of, I guess this one should still, the first part of this should still pass because we're only moving one step. Okay, so that did not pass. I guess the other thing is that when we divide by 2, I think we want the ceiling of this. Seal? I don't know. Let's just see. No. So we expected 2 and we got 5. So from 1 to 2 is 1, right? From 1 to 2 is 1. Okay, so position minus 2. So 1 minus 2 is -1. The absolute value of that is 1. So then we get 1 times 2, which is 2, divided by 2 is 1. Dot seal. Oh, you know what? This might need to be a float too. Okay, so let's add a breakpoint in here. By bug. Acquire by bug. I spelled it wrong. Okay. All right. So n. Oops. Puts n. Puts the position, puts n. Wait, why is it 1? Oh, wait, hold on. We were overriding the value of n here. So this should be like x or something. Yeah, let's call this x. X. All right, that bit us. Let's see if this works. Okay, so that totally works. All right, does this work? Fails. Okay. Oh, but that's okay. So this was the old answer. So we've got to figure out the new answer. So between 1 and 3, we have 1 plus 2. So that should be 3. And then between 5 and 3, we have 1 plus 2. So it's also 3. And then between 9 and 3, we are going up 6. So it's going to be 6 times 7 divided by 2. So that should be 21. So 21 plus 3 is what? 21 plus 3. Let's just see. Okay, that works. Okay, so then does this, no, it's not going to all pass because these numbers are now different. It should give us, yeah, okay, so that gave us the answer there for the test. Okay, so now let's run it again with our input. Okay, let's see. So 96,798,000. That was the answer. All right, so that is the solution for the Advent of Code Day 7. And I guess like the crux of this one was figuring out this sort of math around incrementing. And then also maybe, yeah, we used float infinity as our like sentinel value. So we're starting out with this value that's really big, so that the first time we compare it with some other fuel, we know that we can keep track of that one as the current best fuel. And then ultimately, yeah, we find the answer for where the crabs should sit, where they should live. Cool. Thanks so much for watching, and we'll see you in the next one.